Welcome to another exercise in the workbook statistics. This time I'm going to talk about an exercise on the so-called goodness of fit test. Let's have a look at our exercise. Here we have, it is assumed that the number of lectures missed by students is uniformly distributed across the days of the week. For this, the data in the following table has been summarized. Now we get here the information for the 5 days, Monday till Friday, and how many misses occurred. Our task: test the assumption at a margin of error of 5% by using a suitable test. Well, in this case, we have actual data, actual values, and we have a distribution which this data should follow. Whenever we have something like this calls usually for a goodness of fit test, a chi-squared goodness of fit test. So that's what we're going to do here. To perform the goodness of fit test, I'm first going to copy the table and calculate based on this table the expected frequencies. Expected frequencies, well, we start with the expected relative frequencies. That's what we know from our distribution. We know it should be uniformly distributed, meaning we have 5 days, so on each day there should be on average be 20% of all misses. Well, they should add up to 1. So what we're going to do in the final part is we're going to multiply the overall sum of misses with the expected relative frequencies. Well, here it's always the same since we're talking about a uniform distribution. So we're going to multiply 40 with 0.2, giving us an expected amount of misses per day of 8. So then we have our expected frequencies, our actual frequencies, and we can compare them using the chi-square test. So for the test statistic, this means we're simply, for all entries, all 5 days, are going to calculate, always in this case, actual value, actual frequency, minus expected frequency, divided by expected frequency. So it's always actual minus expected, the result is squared, then divided by expected. We're doing this for all 5 parts here, for the 11, the 8, the 6, the 7, and the other 8. You could do this, as I did this here, by writing it already down, or you could just expand the table by another column, where you then calculate all of this, and in the final row you're going to sum all of this up. There's actually 2 ways. Here I would actually take into particular consideration, do I have every aspect covered, every entry covered? So here I have 5 entries, I need to have 5 different terms. I'm underlying this aspect because that's something which often goes wrong. Someone usually forgets something, or maybe it calculates this for 1 entry twice. So that's absolutely to be avoided. If you might have a problem with this, then just expand the table here and enter in each cell for each row the calculation for the chi-squared term. Well, here we wrote it down. We can then simply calculate this and get as an end result 2. So our test result, or our test statistic for the respective goodness of fit chi-square test will be 2. So the only thing missing to actually conduct the test is the reference statistic. So I'm just going to go with the reference statistic first. Here the reference statistic for this test is always chi-squared, I minus 1, 1 minus alpha. I, that's the number of different rows we have here, or different characteristics, in this case different days. Well, here we have 5 days, so I is 5, 5 minus 1 gives us 4. Finally then, we have 1 minus alpha, alpha is the margin of error, and here we said in the exercise the margin of error should be 5%. So we have 1 minus 0.05, giving us 0.95. Meaning, in the table we're going to look up the chi-squared value for 4 and 0.95. The table then will yield a value of 9.4877. So that's the reference statistic, with which we're going to compare our test statistic. That's in a part of the test decision. So here, test statistic 2, reference statistic roughly 9.5. We see that reference statistic is much larger than the test statistic. Whenever this is the case, we cannot reject our H0 hypothesis. This means that the distribution, the actual distribution of misses does not significantly deviate from the given distribution. So here, our misses across the different days of the week follow more or less a uniform distribution. Well, that's done about everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.